Welcome back to science class, 5th graders. So excited you're here. Today, we're launching lesson 2. First, you need to make sure you have your science workbook and a pencil. Pause the video and grab those items if you need to. Now, I would like you to open to page 83. It should be a purple page. Where do thunderclouds come from? They each have a different idea. Who do you think has the best idea? 3 friends notice thunderclouds forming. It looked like a thunderstorm might be coming. They wonder where the thunderclouds came from. They each had a different idea. Julie says, I think strong winds blew them here from the other state. Doug said, I think they sank down from heavy clouds high up in the sky. And Carla says, I think they formed from warm air rising up into the sky. Who do you think has the best idea? Write their name down. Then pause the video and explain why you believe that person has the best idea. Now I would like you to turn to page 84. Lesson 2. We will discover the effects of the atmosphere. This is our phenomenon. Look at the picture on 84. What is causing this sandstorm to occur? Let's see this phenomenon in action. You studied the photo and you watched the video of the sandstorm. What questions do you have about this phenomenon? Record your thoughts below. Go ahead and pause the video and do so. I want you to think about how might sandstorms like the one pictured affect plants in an area. Did you know dust devils can form in sand and dust storms? A dust devil looks like a mini tornado that forms and ends quickly. Have you ever seen one? Next, I would like you to turn the page to page 86. Here, we're going to see the inquiry activity in action as we watch it online.
In this lesson, we're investigating the effects of the atmosphere on Earth's other systems. Check out the clip of an approaching storm. Storms like this one are caused by a cold air mass and a warm air mass interacting. In this activity, you'll investigate how warm and cold air masses interact. Air and water are both fluids, meaning they have no fixed shape and flow easily. You will be observing water of different temperatures to investigate how air masses of different temperatures move. To investigate the movement of air masses through the observation of water, you will need a piece of cardboard, aluminum foil, a clear plastic bin, 2 measuring cups, 1 container filled with 4 cups of warm water, 1 container filled with 4 cups of cold water, red and blue food coloring. Before you start, make a prediction. What happens when air masses of different temperatures meet? Share your prediction with your small group. Then select Continue.
So go ahead and pause the video and make a prediction. What happens when air masses of different temperatures meet? Go ahead and do so. Let's continue.
First, prepare the water and the cardboard. Wrap the piece of cardboard in aluminum foil. Make sure you cannot see any of the cardboard. The aluminum foil helps to waterproof the cardboard. Next, put 3 drops of red food coloring into the warm water and 3 drops of blue food coloring into the cold water. Slide the piece of covered cardboard into the middle of the plastic bin. You'll want it to split the bin into 2 equal halves. Hold the cardboard vertically and tight against the bottom of the bin. Have a classmate pour the cold water into one side of the bin and the warm water into the other side. Slowly lift the wall straight up out of the bin. Observe the interaction of the water from the side of the bin for about 2 minutes. What do you notice? How does the warm water interact with the cold water? Draw and label your observations. When you're finished, select Continue.
Okay, so you will record your data on page 87. Go ahead and pause the video and record what you observed when the waters of different temperatures came together. Let's continue.
Next, you'll repeat the experiment using water of the same temperature. Follow your teacher's instructions when refilling your measuring cups. Fill each container with 4 cups of water. Then put 3 drops of blue food coloring in one of the containers. Place the cardboard into the bin the same way you did the last time. Hold the cardboard firmly to the bottom of the bin. With the help of a classmate, pour the uncolored water into one side of the bin and the blue water into the other side. Gently and slowly lift the wall up and out of the bin. Observe the interaction of the water from the side of the bin. What do you notice this time? How do the 2 amounts of water at the same temperature interact? Draw and record your observations. When you have finished recording, select Continue.
Again, pause the video to record your observations. Then we will continue. Let's continue.
Next, use your drawings and data to complete the Communicate Information section.
Okay, let's complete the Communicate Information. Question 7 says, think about the water cycle. Could a cold air mass meeting a warm air mass cause precipitation? Explain. Pause the video and do so. One answer is yes, it could. The warm air mass would rise over the cold air mass and cool. This would cause the water vapor to condense and fall as precipitation. And for our final question today, how did this investigation model an interaction of the atmosphere and the hydrosphere? Go ahead and pause the video and complete that answer. One interaction is the water modeled how the atmosphere and the hydrosphere interact to form different types of weather. That'll be it for today. We did a lot. As we close, I want you to think about it. Did your results support your prediction? And how does tracking air masses help predict weather? Go ahead and talk that over with your adult learning partner. We'll see you next time.